Coming to example 11, watch the graph carefully. You can see the curve is moving this way. Fine. And they mention the graph y equals to h of x. Okay. Where the function h is defined by h of x equals to ax cube plus bx, where a and b are constants. Fine. They mention how many values of x does h of x equals to 0, asking us to find what are the x values when h of x equals to 0. What all are the x values? First, you need to understand y equals to h of x equals to 0. From these two things, h of x. What is h of x here? Y. So I'll just substitute in this, vice versa. So here y equals to h of x equals to 0. I just substituted 0 in place of h of x. What do we need? You can see here clearly for how many values of x h of x equals to 0. There are some values of x. For those values of x, h of x equals to 0. But what are those x values? So here h of x is 0 is same as y 0 from these two conditions. We need to find x values. We don't know how many x values we have. We have to find those x values y equals to 0. Why? H of x is same as y. So that's why y equals to 0. But how can we find the x values? Watch the graph carefully and consider the information y equals to 0. What does this y equals to 0 telling us indirectly? We learned a concept called x intercept. At x intercept, y values are 0 or not? All At all x intercepts, y value is definitely 0. So we are looking for some x values at x equals at y equals to 0. Sorry, y equals to 0. What is x value? X intercept. So indirectly we have to find x intercept on the graph. Now let's look for the x intercepts on the graph. See this curve, it started here, it crossed x axis at this point. So that is the x intercept. You already learned x intercept means wherever the line curve crosses the x axis, that particular point we consider it as x intercept. So this 2 is the x intercept now. So that is one of our value, x equals to 2. One value we got. Let's move along with the curve. See, this curve is moving like this, and where it is crossing x axis, 0. So that is the another x intercept value, which is x value. Why we are focusing on only wherever it is crossing? Because we are looking for x intercept. Why we are only looking for x intercept? Because we need x values at only y equals to 0. We don't need other x values where y equals to some other value. We need x values at definitely y value must be 0. So that is the reason we are looking for the x intercept. Why x intercept? At x intercept only y value is 0. At x intercept, let's say you got here 1, 2. At x intercept only, 2 is the x intercept. Y value is 0. Here if our x value is 2, what is y value? 0. Go to here 0. It is not even 1. If at least we have here, then x value will be 2, y value will be 1, but it is not like that. It is x value is here, which means y value is not even 1, it's not even up. So it is 0, y value is 0. So in the same way, let's move along with the curve now. We have to check where the curve crossing x axis. It is crossing at negative 2. So that point is our x intercept. Why? There y is also 0. It is crossing x axis. X intercept means where the curve or line crosses x axis, that particular point we consider it as x intercept. So we got negative 2. So done. These all the x values we are looking for at y equals to 0, at h of x equals to 0. H of x equals to 0, y equal to 0, both are same because h of x they mentioned is y. So at all y equals to 0, the values of x are 2, 0 and negative 2. From where we got this? from the graph where they are crossing. I mean, the curve we have that is crossing at 2, and again it crossing at 0, and again it crossing at -2 on the y x axis, sorry, on the x axis.